Okay, so today we're moving on from looking at the global hydrological cycle to looking at the drainage basin system. So the title is What Affects the Processes that Operate in a Drainage Basin System? And first of all, we need to understand what the characteristics of a drainage basin are and then look at what factors affect them. Now, the first thing to mention is that a drainage basin system is an open system, because a drainage basin system does have inputs and outputs. So, for example, water enters the drainage basin system from the atmosphere, so from the climatic system. So rain falls out of the sky and enters the river, and water leaves the drainage basin system by entering the sea, and then it becomes part of the coastal system. So this system, it has inputs and outputs very much like the coastal system, but all of those systems are part of the global hydrological cycle, which is a closed system. Okay, it's really important that you understand the difference between open and closed, and the global hydrological cycle and the drainage basin system. You can see a picture of my daughter on this slide, and she's got her own little YouTube clip which explains the hydrological cycle if you want to have a look. Okay, so on the syllabus, you should all have a copy of this learning pattern. We're on the second question, 5.2. The drainage basin is an open system within the global hydrological cycle. So the drainage basin system is part of the global hydrological cycle, but in order to understand it, we need to understand about how a drainage basin actually works. So if you look at the sort of little sections, some of this you probably already know, but what we're going to really focus on is how the drainage basin has several processes, so inputs and outputs, explain how physical factors in the drainage basin change and how that makes the difference between the different processes, and then quite importantly how humans can disrupt the cycle and the systems. Okay, so the first thing is this is just a page from the revision guide. So if you've got the revision guide, it's quite a useful page. It's on page 20 of the A-level revision guide. And it tells you a little bit about what a drainage basin is. So you can see the image on the slide. Obviously, if we were in a lesson, I'd be drawing this for you. Basically, the boundary of the drainage basin, so in this diagram, it's the yellow line, is called the watershed. And what that means is if it rains, any rain that falls within that boundary will eventually be trying to make its way to the river. So some of that water will get intercepted by trees. Some of it will evaporate back into the atmosphere as an output. Some of it will soak into the soil. It will infiltrate, and then it will flow through the soil to the river or into the sea. Some of it will flow directly into the river, overland flow, or surface runoff is another name for that. And some of it will actually saturate right down, percolate right down into the deep groundwater storage, into the aquifers, and replenish the fossil water that we talked about last lesson. So drainage basins are pretty complex. They rely on inputs, which would come from the rainfall. Their outputs can be out towards the sea or evaporating back into the atmosphere. Or you could argue that an output would be it becoming fossil water. So one of the things you need to know for your A-level is the processes. So you need to understand what all of those words on that diagram mean. And in the glossary that I gave you a few lessons back, some of those words are on the glossary, so it would be worth looking them up and actually filling in your glossary for that. And again, here's some of those processes. So interception, for example, is where the plants intercept the water. So as the rain falls, the leaves either collect the water or the roots from the plants absorb the water, take it up into the stems and so on of the plants. Some of the water gets evaporated, some gets infiltrated, etc. So some of you might want to draw that diagram out, others might just want to include the words on your glossary. That's just another diagram if you wanted to print it. Okay, the next thing is, normally in lessons I'd be giving out these photographs and you'd be looking at them, but I'm going to just talk you through each of the photographs and try and think what's happening in the photo. I'm going to give you some hints, but you might want to spend a bit more time looking at the photos and thinking about how it could impact a drainage basin system, or even think about any questions you would ask. Okay. So photograph A shows deforestation. Okay, so you need to think about how deforestation would affect a drainage basin. So deforestation, you're removing trees, and if you're removing trees, you're going to reduce the process of interception. So as a result, more of the water is going to reach the land and flow as overland flow to the river. So deforestation can increase flooding in the drainage basin. It can also cause problems because less water is being taken up in the roots. And eventually deforestation can lead to massive changes in climate as well, because you've got less evapotranspiration and therefore less clouds being formed, and therefore eventually less rainfall, which is happening in the Amazon. So it all depends whereabouts the deforestation is taking place as to the exact impact. But one of the biggest impacts is reducing interception. Okay, so this shows an area of mountains. So what impact is this going to have on the drainage basin? Well, often snowmelt or glacial melt is what begins a river's journey. So many rivers around the world rely on snowmelt to feed them. So, for example, the three main rivers that flow through Bangladesh, the Ganges, the Meghna and the Brahmaputra, all rely on snowmelt from the Himalayas. So straight away, this snow represents a massive input of water to the drainage basin system. It can impact a drainage basin system because when you get to spring, there's going to be more snowmelt. And where there's more snowmelt, you're going to lead to an increased risk of flooding in the drainage basin. Conversely, where you have winter and there's more of this ice frozen solid, there's going to be a lower flow of the river. Any changes to that pattern are going to have an impact downstream. So, for example, Bangladesh are used to Himalayan snowmelt happening at certain times of the year, but due to climate change, it's happening at different times of the year, and leading to flooding, and the people in the lower reaches of the river struggle to manage the flow. Okay, this is farming. So this is like land that's just been cleared for farming, and it's parched. It's completely dry. There's been a drought. And how's that going to impact the drainage basin system? Well, the rivers run dry. There's not enough water to supply the river. The river runs dry, and that flux of water from the land to the sea stops. Okay. This could be because of things that humans have done. So it might be that upstream of the river, people have built dams, which has then trapped the water, or it could just be climatic change that has simply led to a lack of rainfall. But the impact on the drainage basin is that as the soil becomes more dry, it actually becomes more impermeable. So any rain that does fall is likely to flow straight into the river and maybe cause flooding. Okay, this is the River Nile in Egypt. This is where it flows through Cairo, and basically what this shows is huge amounts of urbanization on a floodplain. So you can see the land around the River Nile is really flat, it's really low lying, and it's also really fertile. So historically, this is why the Egyptians chose to live along the River Nile. And if you look at a map of Egypt, a population density map, you'll see that all the way along the River Nile, there's a really high population density, whereas the remaining parts of Egypt, it's really sparsely populated because it's pretty much desert. The impact this has on the drainage basin is if you've got vast amounts of urban area adjacent to the river, that means you've got more concrete, more tarmac, which is impermeable. And therefore, when it does rain, the water is going to run straight into the river and potentially cause flooding. It also means that people are going to require that water. So they're going to be abstracting the water from the river. and they're also going to be polluting the river. So sewage and waste products are going to go into the river, which is also going to affect the ecosystems of the drainage basin. Okay, this is the Hoover Dam in America, River Colorado, and it's a huge structure, and the purpose of a dam like this is to basically hold back the river. So hold back the river and create a reservoir where you can use the water to provide humans with drinking water. So some of the water from here is actually taken 333 miles across the Arizona desert to the city of Phoenix to supply that city with water. But the way that it impacts the drainage basin, and we are going to look at a case study on the River Colorado, is that now the river no longer actually enters the sea. There's no longer enough water flowing into the lower reaches of the River Colorado, which means that the river delta there has just dried up, and that flux from the land to the sea has stopped. Okay, this is the canal that I was talking about that transports water basically across 336 miles, actually not 333. It affects the drainage basin because it's taking water out of one drainage basin artificially and putting that water into another drainage basin system, which upsets the balance. Also, it causes more evaporation because, as you can see, that channel is completely uncovered and it's really hot sunshine, and as a result there's going to be rapid evaporation on the surface of that water. Okay, this just shows saturation. So where places have had lots of rainfall over a prolonged period of time, the soil becomes full of water, soil moisture recharge, and if there is a surplus of soil moisture, so there's too much water, then it causes flooding, basically. That water tries to get to the river, it causes flooding, and that can cause damage. Okay, this is another water transport system. So similar to the one I've said before, so it's altering the system artificially. You can see how dry that area is as well. Steep-sided mountains like this have an impact on a drainage basin because it's really hard, impermeable rock. So when it rains, there's nowhere for that water to go. It will just literally gush down through the river, through the channels, through the V-shaped valleys to find a channel to flow through. So areas downstream of this would flood really rapidly if there was a heavy rainstorm. So that's just some of the factors that affect the drainage basin cycle. What you're going to do is fill in the sheet by picking different ways that humans disrupt the drainage basin system. So farming, irrigation, deforestation, abstraction of water. I've listed things there. And then I want you to try and explain how it disrupts the cycle using some of the terminology. So I want you to talk about interception, infiltration, impermeable surfaces, permeable surfaces, that kind of thing, so that you're actually using the processes to explain the impact on the drainage basin cycle. And then hopefully, if you can, do a little bit of research to find a case study example that supports that. Okay, so these are some of the factors. So natural movement of water within a drainage basin is controlled by solar energy and gravity. Different factors control how precipitation reacts on reaching the land surface. So the relief of the drainage basin is going to have an impact. So is it a steep-sided drainage basin? Is it a U-shaped drainage basin? Is it a huge drainage basin like the River Nile? What's the climate like? Are there clear seasons? Does it rely on snow melt? The geology, is it impermeable, resistant rock like granite, or is it boulder clay like on the Holderness coast? That's going to have an impact. The land use, so like for example the River Nile, Cairo is a really built up area, whereas other parts of the drainage basin might be open land or agriculture. Or the River Amazon, for example, flows through the Amazon rainforest, which is heavily forested. That links into vegetation. Drainage density is something a bit different. So that's an extension task if you want to find out what that means. But basically, all of those factors are really important in looking at each individual drainage basin and why it behaves in the way it does. There is a website there which have some kind of factors and flashcards which are quite useful as well. And finally, where is this place? Okay, if you want to comment, you can comment on Show My Homework, and we will talk about this in our next lesson. Okay, bye.